In this video, I will show how to do an optimization problem with the constraint. So let's read the question, and here we have a standard garden problem where we're constructing a fence with one side already fixed, so we can only control the two widths and the length. And first question is to figure out what is that we're trying to maximize or minimize. So this function is called the objective function. So the objective function in this problem is the area, because we're trying to find the maximum area. So that means we have to figure out the expression for this function. So since we have control of W and L, we know that the area can be found by multiplying W and L. So as of right now, the area function is a function of two inputs because it depends on two variables. We don't know the tools yet how to maximize or minimize the function of two variables. So we have to find a way to rewrite this as a function of one variable. And what can help us with this is called the constraint function. So constraint function is an additional relation in the problem that somehow relates the two or more variables and allows us to isolate one variable in that expression, in that equation, and use that expression in our objective function instead of the second variable. So the constraint function, so we have to look for the constraint basically that relates W and L. So in other words, what prevents W and L from growing indefinitely? It's this. So the total length is 100 feet. So that means 2W plus L is equal to 100 feet. So now, using the constraint, I can isolate L in that equation. And now I can take my expression for the area that I'm trying to maximize, and in that expression I can replace L with the equivalent expression. Now, what do we achieve by doing this? Now, my area does not depend on L, it only depends on W. So now we have area as a function of W, and it's a function that we know how to handle. So if I'm looking to maximize the area, I have to find the critical points first. So let's find the derivative of this function. Let's set it equal to 0, or find the values where it doesn't exist. Since this is a linear function, it always exists, and we only have to find the values where it's equal to 0. So solving this equation gives us the output W equals 25. So what happens at 25 we can find out by constructing the sign chart for the derivative. The derivative to the right of 25 is negative, and to the left of 25 is positive. So that means the function is increasing here and decreasing here. So at 25 we have absolute and relative max. So to answer the question, we have to find the maximum area. So what is the maximum area? The maximum area is the value of the area function at 25. So it's negative 2 times 25 squared plus 100 times 25. So 25 squared is 625. 625 times 2, it's 1250. and 100 times 25 is 2500. So the answer is 1250 square foot is the maximum area.